All right, so to recap back for the audience, this decision tree concept, definitely extremely easy to understand with a visual.
Yeah. Yeah, for
But
sure.
it's the idea, yeah, the base of a tree, which for some reason, I guess because it ends up being on the top of the diagram
Yeah.
because we read from top to
Top
bottom.
to bottom.
So
Yeah.
it makes sense to have the flow be from top to bottom. But that means that the tree shape is upside down. The base of the tree or the root of the tree is the starting point, and you have your first split right at the very top. Typically, I think with most of these approaches, I'm not the expert. I think you're much more expert than I am, but typically that first split is it's often the most important split. Like it's the split that'll get you your biggest delta in whatever outcome. So in your case, like is somebody likely to spend a lot of money on candles on my website or not? That first split will often be a variable amongst all the variables available that is going to get the biggest it's going to have the biggest
Yeah.
relationship, yeah?
Yep.
So in this case, in
That's
your
right.
example, it was income, which makes a lot of sense.
Yeah.
People with more income are more likely to spend money on
Yep.
candles on your website. And then from there, yeah, it goes you go two ways on this path, on this tree of possible decisions. I guess
Mm.
you can imagine it like going on a journey and
Yeah.
you're walking along a path and the path splits in two. All of the people with high incomes go one way, all the people with low incomes go the other way. And then once you get a little bit further along the path, the people with the high incomes, they encounter another split in the road, and this
It's
time it's
age.
split on age. Yeah, and so
Yeah.
all the
Oh,
young
no,
high earners.
sorry. It's not a. It's that's for the high earners. For the high earners, it's loyalty program.
Oh, right. Sorry, yeah, I missed it. But yeah, but for the visual analogy, the higher earners, they're going along their path in the woods, and then it splits again a little while later, and some of the high earners on the loyalty program go one way, the high earners that aren't go the other way, and the same thing happens on the other side. But like you said, it doesn't necessarily need to be symmetric, and it doesn't need to be the same variables that you're splitting on.
Yeah.
So the low income earners, as they walk along their path, when they encounter a split, they have to split on their age
Yep.
instead of on the loyalty program. So, yeah, I've never thought of it that way as like the path, but I think that's kind of easy, at least in my head as I'm speaking. It's quite an easy thing to imagine that
I
you're on this
love it.
journey.
I
Yeah.
love it. Yeah. And that's good for like visualizing training because that's exactly how it would happen in training. And then a new candidate that comes onto your website would have to go down this path and look at the signs. I think we should rename decision trees to decision paths going forward. It's brilliant. Seriously.
And when you get to the end, so in this case, so you could have, you know, it's a hyperparameter in your model when you set it up. You could have lots of levels, lots of bifurcations in the path. It's always two, by the way.
Mhm.
There's never like you never get to a point on this journey and there's three possible paths.
Yeah.
It's
Yeah.
always two,
So if else.
always if else, like you said. And when you get to the end of that journey, which is a leaf node. So again, if
Yes.
you imagine the tree
Terminal.
was the terminal node, leaf node, if you imagine that the
Terminal
tree
leaf node.
a terminal leaf node. Yeah,
Yep.
right. If you imagine that the tree was upside down, these would be like a whole bunch of leaves
Yep.
emanating out from the base of the tree. It's like yeah, it's like holding a Christmas tree upside down
Yeah.
after
Yeah.
you've already it's Christmas is over and now you're taking your Christmas tree out of the house.
Yeah.
That's what a decision tree looks like.
Yeah.
And yeah, you're holding it from the base up by your head.
Yeah.
So when you get to that terminal leaf node on our path analogy, then you could imagine that they that you're asked at that terminal point, how much did you spend on candles at the website? And then you can average all the people who got to that terminal node, and you
Yeah.
have different values. So your high income earners who signed up to the loyalty program, they had an average of $212 spent,
That's right.
and yeah, and so on. I, we might be belaboring what decision trees are now to people who were already familiar with them, but for people who weren't, hopefully this discussion has been
Yeah,
helpful for you.
hopefully the people who were already familiar with them forgive us for this slight um, easy kind of concept detour because that was important for everybody to get on the same page. From now on, everything's going to be a lot of fun and we're going to dive into more advanced topics. So right away, I wanted to also say that decision trees can be used for regression, as we just discussed, and they can be used for classification, as you can imagine. For classification, it's even easier you go down these paths, as John was saying, like during training, customers go, and then there's like a question, a yes no question. Did this customer churn, or did this customer not churn? Does this patient have cancer? Does this patient does not have cancer? And based on what you get through training, your final decision tree will either assign. You can set it up to assign a label. So as soon as a new candidate goes through the tree and gets to the end, you can assign a label, cancer or no cancer, or in case of classification problems, you can do that, or you can assign a probability if you like. You can 70%. 20%, whatever else. So it's two kind of ways to set it up for classification problems.
Yeah. So going back to your earlier example of the single decision tree, where three of the variables that you got into were income, age, and whether they were signed up to the loyalty program or not.
Yeah.
And so in a random forest, the first tree in the random forest might only have income and age. And then randomly, the second tree has age and loyalty program, and so on.
Yep.
So yeah, so you get slightly different answers every time.
Yeah, and it's actually a good point to say that trees can reuse variables, right? If it used income at the top and then it used loyalty program in the next split, and again can use income and can use income, like it is not limited to using it feature only once, so it can be done as well. And there's other hyperparameters like the depth of the tree. You could set the maximum depth to 8 or whatever. There's a hyperparameter for random forest. You can set how many trees, 100, 1,000, how many trees you want.